Your Excellency Alfredo Toro Hardy, Venezuelan Ambassador to Singapore, Mr. Chu Xiaobeng, CEO of Keppel Corporation, and many other friends from the Keppel Corporation. Distinguished guests, ladies and gentlemen, it is my great pleasure here to welcome you all to this special event, the inaugural lecture for the Keppel Professorship. In a few moments after having invited Mr. Chu to give some comments, I'll have more to say about today's speaker, but first I would like to recognize the Keppel Corporation, through whose very generous support we have been able to do this. They have been extremely instrumental in helping the Sim Ki Boon Institute becoming a leading research institute in the areas of financial economics and financial econometrics, and obviously with a particular reference to economic policy in Singapore and the region. This support by the Keppel Corporation to the Sim Ki Boon Institute has been recognized by the establishment of the Keppel Professorship in Financial Economics, to be bestowed on academics who have demonstrated an exceptional level of achievement in research in financial economics. And as we all know here, and it's the reason why we're together here, the inaugural holder of the Keppel Professorship, Professor Peter Phillips, epitomizes the ideal for which this award is intended. But before I go into more detail and introduce Professor Peter Phillips, I would like to invite Mr. Chu to say a few words here on stage.
Good afternoon. Your Excellency, Mr. Alfredo Toro Hardy, my good friend and ambassador of Venezuela, Mrs. Hardy, Professor Bryce Will, Dean of the School of Economics, SMU, of course, President, Mr. Andre, and Professor Peter Phillips, distinguished guests, ladies and gentlemen. May I take this opportunity to welcome the family members of the late Mr. Sim Ki Boon, who have joined us today, Peter, Paul, and the family members. I'm very privileged indeed to be here to witness this launch of this inaugural lecture under the Keppel Professorship in Financial Economics, and to welcome Professor Peter Phillips as he leads eminence to this professorship. On behalf of all at Keppel, I am here to honor the memory of Mr. Sim Ki Boon, who was Executive Chairman of Keppel Corporation from the year 1984 to 2000. His demise in November 9, 2007 was a great loss to Keppel and to Singapore, and of course, to his family. For those of you here who may not know him, let me give you a few points of his background. He had a very distinguished public career over 3 decades, where he played key roles in the Ministry of Finance and Ministry of Communications. Our very successful and renowned Changi Airport is one of his many projects, initiatives that still stand testimony to his legacy. Of course, Tanah Merah Country Club, which I involved. Following his retirement from civil service, Mr. Sim extended his leadership and foresight to see Keppel's transformation from a ship repair business into one of Keppel's leading multinational conglomerates. This year, Keppel celebrates 45 years since our founding in 1968. We were the dockyard department of the Singapore Harbour Board then. The Harbour Board became PSA, and the dockyard department became Keppel Shipyard, which became Keppel Corporation. Today, we operate in some 30 countries, employ more than 40,000 people, with passion in our businesses in offshore marine, infrastructure, and property. In tribute to his many contributions to Singapore and Keppel, the Sim Ki Boon Institute of Financial Economics was established in 2008. Since then, the Institute has championed and extended the study of financial econometrics in areas of strategic relevance to contribute to Singapore's economy and to work in the region. We at Keppel are very heartened by the work of the Institute for Singapore's continued growth as a financial hub in Asia, and we thank SMU for its invaluable support. Sim Ki Boon, as our former boss, has been an inspiration to all of us at Keppel. It has showed us what it means to be a tough man with bold vision. He led by example, he championed inclusiveness and believes in empowering others. And in spite of all his achievements, he remained very humble and rooted to the ground. I believe the professorship will reflect the same spirit, which was to lead with vision and empower others into the future. We are indeed honored that Professor Peter Phillips will be the first distinguished scholar to advance education and research in financial economics in SMU. Look forward, together with all of you, to be provoked by this gentleman. Thank you.
Let me now introduce quickly Peter Phillips. Although introducing Peter Phillips, introducing him quickly is a very tall order. The inaugural Keppel professor, Peter Phillips, as I said before, epitomizes excellence. It is excellence manifested in many ways, as Peter's contributions have been vast. If I really took the time to know them in detail, there would be almost no time left for the lecture. So I will be very selective in my coverage. He's one of the most prolific and influential econometricians of his time. He has published more than 300 articles and is ranked first among economists worldwide for the number of journals pages in print. He has also written or edited 4 books. He made really seminal contributions in a wide range of areas, from finite sample theory to asymptotic theory, from frequentist approaches to Bayesian approaches, from discrete time models to continuous time models, from parametric models to non-parametric models, and from estimation to testing and model selection, from time series analysis to microeconometrics and panel data analysis. You see he has covered it all. Peter's research has substantially impacted not only the theoretical development of econometrics today, but also the practical applications of that discipline, especially for empirical researchers who use non-stationary or nearly non-stationary time series data or panel data. As a consequence of all this hard work and this influential and impactful work, he has been recognized by many institutions, and he's a fellow of several prestigious societies and academies, including the Econometric Society, the American Statistical Association, the Royal Society of New Zealand, the American Academy of Arts and Sciences, and the British Academy. He has been invited to present the discipline's most significant named lectures, including the Marshak Lecture, the Fisher-Schultz Lecture, the Hannon Lecture, and the Sargan Lecture. It would be correct to conclude that Peter loves what he does, but this is not restricted to his own research. He is known for his generosity in sharing ideas with colleagues and students, and we are the beneficiary of that here at SMU. He has collaborated with many econometricians and has supervised or co-supervised more than 60 doctoral dissertations, many of his students now holding prominent positions in leading research institutions throughout the world. And they have become a real family for Peter, and they have contributed together a lot to the field. He has made fundamental contributions to the profession through his service and initiatives with journals, professional bodies, and conference series. Among this is his founding of the journal Econometric Theory in 1984, which he has edited ever since, establishing an annual award and also a prize in honor of Tjalling Koopmans. Peter received his bachelor's degree in economics, mathematics, and applied mathematics, and his master's degree in economics with first-class honors for the University of Auckland. He received his PhD from LSE, London School of Economics, in 1974, and held positions at Essex and Birmingham before moving to a professorship in economics and statistics at Yale in 1979. In 1989, he was named Sterling Professor of Economics, Yale's highest academic rank. Since reducing his appointment at Yale to a half-time in 2004, Peter has taken up appointments elsewhere, including a visiting professorship here at SMU for the period 2005-2007, and a distinguished term professorship since 2008, when he assumed the co-directorship of the Sim Ki Boon's Institute's Center for Financial Econometrics. His recent work on detection of asset price bubbles, done in collaboration with the Sim Ki Boon Institute director Jun Yu, is the perfect example of fundamental methodological development with direct importance for central banking policy and other financial economic applications. You see, he is really the right person to become the Keppel Professor, and I would like to congratulate him from my perspective as president for that. Ladies and gentlemen, please welcome Professor Peter Phillips.
Well, thank you very much, Arno, for those glorious words of praise, much appreciated. And thank you, Gladys, who's standing in for our wonderful Dean Bryce Hall, who unfortunately is ill, returning from Thailand over the weekend. So thank you, Gladys, for that. So thank you all for coming to this inaugural lecture. It's a long time since I gave an inaugural lecture. The American university system does not have that tradition. So the last inaugural lecture I gave was in Birmingham in 1976. That's, that's 40 years ago, and probably well before most of my students, current students, and faculty and colleagues were born. Now, in the British tradition, which is extremely formal, as some of you will know, you get a letter from the Vice-Chancellor, which is impossible to refuse, inviting you to give a lecture to the university community at large, including spouses and partners, and to educate them about what it is that interests you and your field in general. So this is a rather daunting task for a young professor. For me, I was only 28 years of age at that point, and so as a first inaugural lecture, it was particularly difficult. However, I learnt that the task was really quite simple. All you needed to do was entertain the Vice-Chancellor's wife, while at the same time not appear a fool in front of your colleagues. So the task today is really something similar, but on its head, so to speak. It's to entertain my students and colleagues without appearing a fool in front of the captains of industry, represented by the august Keppel Corporation. As you know, or as everyone knows, the Keppel Corporation is an industrial giant in Singapore. In many ways, this industrial giant is the embodiment of Singaporean success, all the successes of Singapore, its struggle for excellence and its multiversity, and its capacity to grow quickly and be integrative. So it's a particularly great honour to me to be selected for this Keppel chair in financial econometrics, and I'm grateful to the senior management team of this university, SMU, and to the Keppel Corporation for this appointment. Of course, these days, as distinct from 1976, there are very strong linkages between the university sector and industry. In fact, there's a broad recognition that we need to invest in human capital as well as physical capital if we're going to promote a knowledge-based economy. And SMU, by its very name alone, is a testament to that linkage between industry and the university sector. So the subject of my talk today is trends, or trend, if you want to use a generic singular, and mystery of trends, as you can see from the title. So, econometrics is the vehicle by which we learn more about trends, the way we manipulate and massage the data so that it can reveal at least some of its secrets to us. And that's, of course, my main field of technical interest. But trends are really ubiquitous in modern society. We can't pick up a newspaper without learning about trends. We have trends, social trends in crime and in divorce and marriage and the like. We have the financial pages of the newspapers covered with technical analysis of how stocks and commodity prices are doing. And of course, we need only look around the physical world around us to see daily the changes that are taking place. Now, I'd like to draw attention to the fact that last year the Prime Minister of Singapore gave a rally speech in August 2012. I wasn't here to hear it, but I did read the speech. And in that speech, the Prime Minister enjoined the island community of Singapore to think about its future, to create a future story, if you like, about Singapore. The Singapore story of the past having already been well told. And in that lecture, the Prime Minister drew attention to several ongoing trends in Singapore. He drew our attention to all the technological developments and infrastructure changes, transport communication, looking to the future, robotics, IT, unmanned flying vehicles and the like, as well as pointing to improvements in areas, social areas like healthcare, which would be desperately important for the future of this country. These were, in a way, positive trends, but he also gave attention to some negative trends, remarkable for Singapore. Not so good behaviour, some of you may remember from that speech, which struck me particularly because to me Singapore is possibly the safest country in the world to visit and live in. But he also drew attention to ageing demographics, which is an extraordinarily serious problem. And as he put it, too few babies. Well, vast though the subject of econometrics is, it's really not possible for econometrics to address that particular problem. You know, we don't have the tools of that particular trade, let us say. Nonetheless, aging demographics and low fertility rates is something that we can measure, report on, analyse and study in relationship to developments elsewhere in the world, where of course there are significantly falling birth rates in many countries. And this is in fact the main role of econometrics in terms of informing policy. So hopefully some of the work that we do in our work on trends and in the SKBI Institute will turn out to be helpful with regard to this national conversation that the Prime Minister of this country called for. So let me talk a little bit and move to navigate the slides to some more general trends that I want to draw your attention to. Of course, there are two in the left and right panels of this title slide that I'll get back to momentarily, but I need to navigate to the end of this document. So there, of course, is the Keppel growth up to 2008 from its origins as a small shipyard in 1968, as the Chief Executive Officer pointed out to us. And you could fit a line to these points, and of course, if you did, you'd see that they're going up. So these are revenue and after-tax profit for the Keppel Corporation. Here's the population of Singapore, which has grown from 2 million to 6 million over what's a relatively short period. So the country is a small, rather crowded island, but it manages to do a great deal in the limited space that it has available. Some of the things that I'm going to be talking about in this lecture relate to climate change, and with respect to climate change, the impact on Singapore is likely to be substantial, more particularly because of its limited land resources. Now here's a more complicated trend, carbon dioxide emissions per capita. Now carbon dioxide emissions are growing up substantially throughout the world, but of course relative to either GDP or relative to population, which are both themselves growing trends, you have a ratio of trends, non-stationary time series, and the behavior of such ratios tends to be substantially more complicated. And as you see in this graphic, it's rising and falling. And of course, this is one of the things that China is particularly interested in, the per capita measurement. And then, of course, as a final graphic for Singapore is the epidemic dengue fever statistics, which are now rising up to 700 or 800 per week. And this graphic taken from the Ministry of Health website shows how the 2013 data significantly differ from the stable equilibrium dengue fever reported statistics of 2012. Essentially the difference between a stationary and non-stationary epidemic series. So to go back to the leading slide, on the left panel here we have carbon emissions that are anthropogenic driven, and not all of them, but a selection of them. And you can see that it amounts to 9 billion metric tons a year from those various sources, coal, petroleum, and so on, not forest burn-off. Now, that needs to be seen in the perspective of the amount of carbon in the atmosphere. The amount of carbon in the atmosphere is around 850 billion tons. It's about 4% of our atmosphere, 0.04%, sorry, of our atmosphere. So clearly those trends show what's happened over the last 200 years since the Industrial Revolution. Now on the right-hand side sub-panel, we see that data in the inset taken over a 1 millennium period, AD, relative to what's happened over 400,000 years, where the data is drawn from ice core segments. And you can see from the graphic, and we'll be showing many more of these graphics later on in the talk, that the present level up here is around 398 parts per million, is substantially greater than anything that's been observed over the past 400,000 years. In fact, it's substantially greater than anything that's been observed since a period about 50 million years ago, as we'll show in some other graphics. So as we say in the subject of econometrics, we're now operating outside the sample space of actual experience. And this is one of the reasons why study of climate change is so extraordinarily difficult. And perhaps the only way we can really address this seriously is to look at data over very much longer periods where we're operating within the same sample space as we would be now. And so during the rest of this lecture, I'll be saying much more about that. So, just to step back a little bit, let me start with the question of what is trend. We all have a very general understanding of that because it's such a popular term. But if you look up the dictionary, the modern dictionary definition of trend is general course or tendency of events. General course or tendency. You may not be aware, but that terminology is very recent. It developed towards the end of the 19th century, around 1884, when economists started to discuss and analyze data such as trade flows, exports and imports that were recorded much more frequently. We didn't have GNP statistics in those days, of course, and prices and interest rates. And what they noticed was that the dominant feature of all of these data was that they tended to drift away from what might be considered some standard mean level. So they weren't stationary about some equilibrium level, they drifted. And so this word trend, general course or tendency, came to be introduced to capture that notion. And it's stayed with us ever since. Somewhat earlier, if you go into the etymology of this word, the word trend came from Old English, the verb trenden, which meant to wander. And you can think, you wander away from the mean, so to speak. And the usage was essentially to characterize the way in which a river or stream might wander its way through a plain towards the ocean, or a coastline, the way it would wander around bays and headlands. So the meaning shifted actually as economists started to collect data and analyze data. It's a curiosity in the subject that we now think in terms of trends much more closely to the original definition of a wandering process. And that's one of the big changes in the subject that I'm going to talk about. Nonetheless, the modern usage of the subject, certainly the one that's familiar in the press and in most modern treatments, relates completely to this idea of general course or tendency. And there are many examples. For example, senior public figures in economics, like central bank chairpersons, not looking at anyone in particular here, but central bank chairs, governors and treasury secretaries use this type of terminology very, very frequently in expressions like, if current trends with fundamentals continue, then we can taper off quantitative easing in the next 12 months. Okay, we've heard that very recently. Yeah, a newly emergent trend is the declining growth rate in China and its implications for the rest of the world. Long-term trends indicate that stocks perform better than other financial assets. So we hear these types of expressions very frequently, and in many ways they have an authoritative ring to them, an evidentiary ring to them, as if there's some science and evidence brought to bear. And indeed, central banks and treasuries spend an awful lot of time analysing the data, and one can expect that there is evidence behind such remarks. On the other hand, to the general public, what do these things actually mean? Trend isn't defined. What is it, some line or curve or whatever? what is current, newly emergent. All these epithets add up to a rather authoritative sounding statement, but in practical reality, we're being a little deluded. They're somewhat misleading. And so this is one of the issues that we have in any discipline. How can you measure something that's not defined? We have to define the object first. So from a certain perspective, it's reasonable to say that no one really understands trends, but everyone sees them in data. Every time you look at a cloud of points, a scatter plot in data, test yourself on this, and I will tell you in advance that it's true. You will see a line in that data. You look at data and you have this irresistible impulse to run a line through the data. This is a basic human instinct. Where does that human instinct come from? The human instinct comes from the need to bring order to disorder. And this goes back much more than millennia. It goes back hundreds of thousands of years into the origins of the human species. It's our one talent, to bring order to disorder, to understand the ever-changing world around us. So we see a cloud of points and we run a line through it. But think about that line. When we run a line through a set of points, it has certain characteristics. It appeals to us because it tells us where we've been, where we are now, and where we're going. It carries a direction vector with it. And those of you who learnt calculus will know that this is because it's a differentiable curve. So at the last data point, when we draw a line through it all, we get a direction vector to the future. And it's that direction vector to the future that's so integrally important to this line of thinking. But as I said, this is just an artifact of the human mind. It's like eyeball regression. You know, we do this mentally with our eyes, even though we have a whole lot of techniques, sophisticated regression techniques that do it for us. All of those regression techniques are built on models. All of these models are fundamentally wrong. And who are we to say that it might be worse or better than just drawing a line through a set of points? But of course, there are actual limitations to what human beings can do with drawing a line through a set of points. Usually we don't take the line off the paper. You know, we don't put kinks in it. And as I said, it tends to be continuously differentiable. So one of the greatest changes in econometrics in the last 30 years has been the recognition that trends have random elements in them. Trends are stochastic, fundamentally stochastic, so that we recognize that at each point in time there's enough randomness in the data frequently for us not to be able to provide a direction vector. The most obvious example of this, of course, is stock market data. I mean, we'd love to have a direction vector there, but you know, and of course, a large amount of journal space has been devoted to trying to find direction vectors by predictive regressions. You can amass thousands of potential explanatory variables and run regressions of this sort in order to identify what may be the main determinants. The same thing is done in macroeconomics with respect to determining the fundamentals of a growth mechanism in an economy. But most of the time, we recognize that it's a residual, it's a thing that's left over, the thing that we don't have observations on that tend to be the driving mechanism. So the modern econometric interpretation of these ideas is that we have to integrate the fundamental stochastic nature of the data into our trending mechanism. We do that with rather sophisticated models in finance and financial economics, using the structure of a martingale, where the best predictor of tomorrow's price is today's. So, you know, in the absence of anything else, you just keep things level. The origin of the term martingale, which is everywhere these days in finance, comes from equestrian pursuits. There's a strap that goes from a horse's girth to its bridle that holds it back, keeps it under control, and that strap's called the martingale. And so a martingale stochastic process holds back the process from wandering too much so that its conditional mean is its last observed value. So this notion and the idea of unit roots in data are really fundamental. And this is where the notion of mystery comes from, because we look upon these types of trends as being fundamentally rather baffling. We don't really know where they're going to go next. And so I like to say that it's analogous to the protagonist in Shakespeare's most famous play, Hamlet. You never know what he's going to do next. And that's what makes it so exciting. So what I'm going to do in the rest of this lecture is talk primarily about climate change and see what econometrics as a methodology can do to enlighten us about some of the risks associated with this process. As you know, this is a topic that's been very heavily in the media for, well, 15 odd years, but more particularly since the Stern report in 2007. Although it wasn't explicitly mentioned in the Prime Minister's rally address, it is certainly something that is very much in Singapore's consciousness. And they have a National Climate Centre Secretariat that's designing ways of addressing some of the changes that are likely to come in association with this climate change. So, very important both globally and also nationally. So, I'm not sure where I go from here, because as you can see, this is a rather long introduction. So, anyway, here's, actually this could have just stayed on as an introduction. But I do have quite a lot of slides, so I'm not sure how much time I have to get through them. But I'm not sure whether anyone would know what that is. I'm not sure it comes out very well on the screen. But it's a 100-foot cliff in Alaska on a tributary of the Colville River, one of the main rivers in Alaska that flows into the Arctic Ocean. And it's called the Stinking Cliffs because that's dripping carbon, rotting organic matter, permafrost. It's melting permafrost in the northern hemisphere. This doesn't seem to work. Might need a new battery. Does it need to be turned on? Yes. Perhaps you can, oh, it seems to have activated. I can work from here while you fix it, perhaps. So, climate change, melting permafrost cliff, this 100-foot tall. This permafrost is embedded with organic matter, which when it melts, it rots. And that's why they call it the stinking cliffs. And it gives off methane. Methane, CH4, is perhaps the most powerful greenhouse gas. It's 20 to 25 times more powerful than carbon dioxide. It has a lifetime of about 20 years in the atmosphere, whereas CO2 has a half-life of about 1,000 years in the atmosphere. So there are really significant differences between those two. These people show the height of the cliff, essentially. So methane is something we have to worry about. With regard to the melt area in the Arctic more generally, this is a graphic with a line through a set of points, as you can see, from an article, recent article by James Hansen, who's the world's leading paleoclimatologist at University of Columbia.